These agents are currently being trained in real time using Unreal Engine 5's new machine learning plugin to learn to fight in a directional combat game called Swordeye. And these two agents are just a few of many that are all being trained simultaneously and sharing data as they learn across each other in real time. And this uses a combination of imitation learning and uh, reinforcement learning. There is an official tutorial from Epic on the reinforcement learning component, so I'm not going to go as in depth to that. But as far as I know, there is no tutorial out there on how to set up the imitation learning. And for a pretty wide range of problems, the imitation learning will save you a huge amount of training time or potentially allow you to find, to use machine learning to solve problems that are very difficult to solve with reinforcement learning alone. So without further ado, let's get into how I set that up. Okay, so before we go into the code, I wanted to briefly explain Swordeye's combat system, both so that you guys can understand, what we're trying to do, and also kind of understand what makes problems like this challenging for reinforcement learning and how you might overcome some of the challenges you're likely to face in your own games. So I set up just as multiplayer, so there's just a player no one's controlling that we can whack a little bit here. So Swordeye has 6 directions, so you can block or attack in 6 directions. So there's overhead, stab, um, upright, etc. And if you are blocking in a matching direction that your opponent attacks, so if you're blocking down like you're blocking a stab and they try and stab you, then you take no damage and you actually get some benefits that aren't important for this video. Then do you see that little blue bar below my cursor? That's charging up how much damage my attack is going to do. So if I attack very quickly, I'll not do a lot of damage. That did 7. If I sit there just holding the attack forever, it'll decharge and I'll do basically no damage. And the maximum damage is kind of in the middle. I can also combo attacks if I start a new attack right when my previous attack hits, and those do bonus damage. So at a high level, what makes this difficult for reinforcement learning is the other key variable is that blocking takes stamina. And if I switch block directions, I use up stamina very quickly. If I just sit there holding a block, I only use up stamina slowly. And so from a reinforcement learning perspective, you imagine something is randomly trying things out, and then when it gets positive feedback, it's doing that more. If it randomly picks a direction to block, the odds of it picking the right direction are very low. Most of the time, it's just burning up its stamina until it runs out. So it's hard to teach something. The reward for blocking only happens when you happen to guess the right direction and you block with the right timing. If you block too early before I actually reach my swing, all you've done is burn stamina. So you only actually benefit from something that's very unlikely to happen by random chance. And that is a hard thing to make reinforcement learning do. You can, overcome that by building in special cases in the reward function where you kind of reward it for being close to blocking right, or you reward it for blocking at all. You just say you're blocking any direction. And I actually did that, and I'll show an example of where that ended up. But that can take a huge amount of training and a lot of work to the extent that you're probably much better off just writing a behavior tree to do it. Okay, so there's a variety of classes you'll need to use, and in this tutorial, I'm going to assume that you've gone through Epic's tutorial on reinforcement learning and focus on the imitation learning. If you haven't, be sure to go check that out. It's in a much simpler use case, but it goes through all the core classes. So the two things I'm going to focus on in this video is the imitation learning and then how to apply both imitation and reinforcement learning together to overcome some of the challenges you're likely to face in implementing reinforcement learning or machine learning in general into your game. So if we're going to do imitation learning, the first thing we'll need to set up is we'll need to record a data set of behavior that our learning agents can imitate. And you can provide that behavior either by gathering it from players or from playing the game yourself, or by gathering it from NPCs that you already have behaving in a way you like. And so in my case, I have a whole bunch of different types. I've set up a behavior tree system that lets you very easily set up different types of enemies that have different levels of aggression, different strategies. And so I have a wide range of combat agents already, and we'll be recording based on them. So the first class you're going to want to make is you're going to want to extend the learning agents manager. So you'd go, blueprint, new class, learning agents manager, and you'd set up your own version of this. And the learning agents manager system is going to require that you add a few components. So you're going to need to add a recorder component, a controller component, and an interactor component. And I'll go through exactly those are the interactor is already explained in the Epic tutorial, but at a high level, the interactor is responsible for observing game data and then acting based on those observations. The recorder is what's going to record our gameplay data, and the controller you barely need. You just call one function from it. I'll show you that in a second. So the initial setup is going to happen in our begin play. And what we're going to do is you don't need to use the switch in your game unless you're doing multiplayer, but my game has multiplayer. So this is just to keep it so that it's only doing this on the server. And this is just a loop where we spawn as many agents that we're going to record, and then in our case, these are going to be the defenders, and then as many attackers as we want. And it's spawning up to the max agent num, which you set. That's one of the built-in properties of the Learning Agents Manager is how many agents to work on. You can start with just one, but the more you have, the faster you're going to build up a nice big data set of recording that you can use for training. So these functions are very simple. They're just spawning one of my units that'll be specific to your game, and then calling the add agent function. And these are just setting some parameters on the unit I spawned. These are not learning agent functions. These are just mine. So you would need to create a actor that you're going to record from, and then you need to call add agent on that actor. And the rest is specific to my game. So now into the core learning agent stuff. For our recording, we're going to need an interactor because that's going to be responsible for observing the game environment and collecting what would be the inputs to our neural network. And then also it's going to be watching our agents that we're observing, so the guys we spawned over here, and recording outputs that hopefully are going to match to what a neural network would want to output to mimic the behavior of that agent. So you just call the setup function on that. Then we're going to need to set up our recorder. So this guy has a setup function also. And all of these components you can find if you go to learning for recorder. We can just do recorder. And learning agents recorder, you'd extend that learning agents interactor, extend that, and they go through doing that in the Epic tutorial on reinforcement learning. Our recorder actually does not need to have any custom code. I didn't even change any of the blueprint stuff. It's just completely out of the box. You just need to make one. You don't need to do anything complicated. So the recorder is set up. You need a recorder object. You need an interactor that's telling it where to get the recording data from. The recorder path settings you can leave at the default. So all you need to do is drag this out and promote to variable, and you're done. And then you're going to need a recording asset. And so that is a data asset that also comes with the Learning Agents plugin. And so you can make those by going to miscellaneous data asset and Learning Agents recording. And when you open one of those up, it'll start out blank. It'll say you have no records. And then as you start recording, you should see stuff showing up in here. And that's how you would know that it's working. So we set up our interactor. We set up our recorder. The controller, again, there's no code at all here. You just make one and it can do nothing. But you do need to have one. So you'll set up that. That also needs the interactor. And these three calls are all the setup you need to do. So when you're actually ready to record, I just put a delay in here to make sure all my guys were loaded in and ready to fight. And then I enable tick on my recorder so that the onTick function will start being called. I call begin recording. and I wait for the duration I want to record. So I'm doing 6-minute intervals. Each of those will show up as one entry here, and it'll be one entry per agent. So this is whatever 1248 divided by 24 is, that many 6-minute intervals of time, one per agent. Then you call end recording, and you're done. And I made this loop. You obviously don't have to do that, and there's going to be delay between loops. Now, one key parameter you're going to want to consider that needs to be consistent throughout is what your tick interval should be. So I chose 50 milliseconds in the Epic example where they're driving a car. They chose 100 milliseconds. But that is basically how often your agents are gathering observations from the world and then presumably acting based on those observations. And in general, if you make that happen as fast as possible, you either may run into issues where you have somewhat odd behavior if there is lag and the tick interval changes, so that you're getting more or less ticks per second. Or it may be that your agents are very kind of twitchy and constantly changing what they're doing if the number's too high. If the number's too slow, it would be like watching a player play with a very high ping. They're going to kind of be acting late and just look kind of sluggish. So picking a number here that is appropriate for your game is important. If you pick something that's way faster than human reaction time, you may get some kind of odd looking behavior that doesn't seem human. I think my number will seem inhuman, but one of the goals of my game is that I'm later going to be doing a different pass that'll kind of select for human level behavior. So I'm not worried about that. I think 0.1 is a fine interval here. I chose 0.05. So the only other thing we need to do in our recorder is on tick for every agent, we're going to call this function I made up. So I'll show you what this does in a second. But basically, this adds the data for that particular agent to the recording buffer. Then we encode the observations, encode the actions, and call add experience, which writes it to the recording. So these three functions you would call exactly as I did. This doesn't depend on your game at all. Exactly what you're going to record depends very much on your game. And you're going to need to think about what inputs and outputs you want to give your agents. So generally, you're going to call set float action on the outputs of your neural network. So in the Epic example, I think that's just one number, but it might be two. And that's what I'm doing here. So this is recording the actions that my agents took. And then the interactor is going to be in charge of recording the observations. And this is where your custom game is going to do a lot of stuff. So you have to, they go over in the Epic tutorial, so I won't cover it here, but you need to list all the observations you want to have your game take, and there might be quite a bit if it's a complicated game. So mine has, the position of your opponent, the location of your opponent's hands, the location of the middle of their sword, the velocity of the sword, all sorts of stuff are in there. So you're going to end up probably with a fair number of inputs, and your interactor is going to call set observations each tick, and that will actually be what's in charge of populating the values for those observations. And so at the end of the day, you're going to be recording all the observations that your interactor sets in its set observation function, and all the actions that you're inputting, calling set float action here. So in my particular case, I think I have 37 inputs and 2 outputs. Since my guys are just learning to block right now, all they're learning is which direction to block. Now, one other kind of neat thing that you definitely want to think about when you're choosing your inputs and outputs is here, my outputs are kind of what the agent thinks the X direction of their opponent's weapon is and what it thinks the Y direction is. So if it thinks the X is 0 and the Y is 1, that would be an overhead attack. If it thinks, the X is 1 and the Y is 1, that would be an up and right attack. And one of the things that's neat about that is if you choose good values like that kind of map to how a human would perceive the situation, then when your agents make errors, their errors are going to be human-like. So with this setup, it's much more likely that an agent would think they should block upright and instead block up, or think they should block upright and instead block down right. That's much more likely than that they think they should block upright and would instead block down left, because they're going to have very different float values for these two numbers. Whereas if you imagine using like an enum for the six directions or something, you wouldn't get that kind of real world physical mapping between your actions and what random noise would likely make you do as a slight mistake. And so for both your observations and your actions, I would definitely recommend thinking carefully about what a human's perception of the situation would be and what a human would be outputting kind of to their hands in terms of what they're trying to think about what button to click. And the more your neural network is doing those things, the more human-like it will tend to appear in its behavior without any further training or filtering layered on top of it. So now that we have our recorder set up, let's give that a quick test and see what it looks like when it's running. Okay, so I've got my little test arena up here again. And if we actually want to record, if everything's set up right, all we need to do is we drag our recorder into the level and we can just click simulate and it should spawn our guys. And then if we go to our functions, we should see that they're being called. So it's calling record player for tick. And we can go to our begin play and see that our timer is ticking down. And you can pick I pick 6 minutes, you can pick any number you want here. The key thing that you'll be able to see is every time it hits that number, you should see records getting added here, and you can click save occasionally. And I recommend doing that because I let it like record a whole bunch of stuff overnight, and then I click save and crash my computer because I think there was too much data in memory. So, occasionally stopping by to click save is important. And you actually don't need a huge data set for the imitation learning. I was surprised at how small a data set is pretty effective. So you need to I wouldn't just get one 6-minute observation. And obviously I have 24 agents, so my 6 minutes of observation is really 144 minutes of gameplay data. You'd want to get, a few hours of gameplay data probably is reasonable, but you don't need to like let it run for days or anything like that. Okay, so after we've got our recorder made, the next step will be to make a imitation learning manager. And so that's going to be a subclass of the same learning agents manager base class that we use for our recorder. And this part is actually super simple. So again, we're going to need to add some components. We'll have the interactor that's going to be exactly the same as before. And then we'll need an imitation trainer. This has no code in it. This is just, and I've changed nothing. So you just add the component and you're good to go. Sorry. And then you'll need to add a policy, which also has no code, but we'll get into that in a second. So with begin play, again, we're just going to need to set up the components we've added. So we set up our interactor first, then we set up our policy. And for that, we'll need the policy, the interactor, the policy settings. You can, again, just do promote to variable and get the default ones. I am not positive, but I believe that there is a bug currently with the imitation training in particular. The policy normally is where you would set key parameters about the shape of your neural network. And I don't think changing any of these values actually does anything. So you can, for imitation learning right now, you can only make a network with these settings. That's not terrible, but it's obviously not great either. It's possible that I am misunderstanding and that is my error and not at all an issue with the plugin. And so if anyone knows what I might be doing wrong, please reach out and tell me, because it's certainly a bit of a bottleneck at the moment. Then the final thing we need to do is give it a neural network asset. And so again, this is going to be a data asset. So we'd go miscellaneous data asset, learning agents neural network, and we could make a new one. And those are, very black box data assets. You can't actually do much in them. All you can do is reset the network. All right, so jumping back to the Imitation Manager. Once that setup's done, set actor tick enabled, and I put in a little bit more complicated code in the tick than you really need. The core thing you're going to do is you're going to run training, which takes as inputs basically all the things we made. If there's anything we're missing, you can just drag it out and click promote to variable to make one. So, just like that. And that's just going to be some settings. Now, the big thing to be really careful of with imitation learning is it is incredibly easy to overfit. And usually what I've found the best result is a very, very small amount of training. We're just going to do like a second of imitation learning, and then we'll let reinforcement learning correct the rest of the behavior. If you have a huge data set of recording, maybe you can imitation train a lot longer, but even then I'd be super careful. So if you do this and run the imitation learning and then go to play with the agent that you've trained purely by imitation learning, and it seems like they're doing something completely wacky or doing nothing, by far the most likely reason is that you overfit on this training step. So that's what my extra code here is doing, is basically stopping the training super early by calling end training. And so I currently have it set to run for 50 ticks, each of which is 50 milliseconds. So this is 2.5 seconds of training is how long I'm doing it. So again, if we actually want to make that happen, we would just need to go and put a imitation manager in, and we'd click simulate. I'm not going to do it right now just because I don't want to overwrite my network that I trained earlier, but you would click simulate, and you should see in your output log when you do that that it's training. It'll tell you it's error, and you can see that ticking down. Here, actually, I'll do it real quick. I'll just make a new network asset. So miscellaneous data assets, neural network. That. Go back into our imitation manager. Change it here. There you go. And open our log. And we'll hit simulate. That's an error from 5.3 I haven't fixed yet. Not actually important. Give it a second. I had a 10 millisecond delay before it started training. You don't need to do that. I just wanted to be able to see the log more quickly. So yeah, you'll see some output like that. And I had it stop, like I said, after 2.5 seconds. The loss will keep going way down. You let it train longer, the loss will go very close to zero. But like I said, you're very likely to overfit. So I just let mine train just enough that it gets a rough idea of what the agents is observed do, and then we're going to use reinforcement learning to handle the rest. Okay, so at this point, we actually already have something that we could actually run because we have our trained neural network here. Save that. So we would just need to do inference. And so let's look at what inference looks like. So we'll need to give it a policy just like before and the same interactor that we used before. And this is, we'll need to spawn an agent to do the inference. So I'm spawning an agent. Here I have, you'll want to make sure your tick interval is the same as your training data. This is just going to spawn one guy so we can fight him and see what it looks like. And as usual, we'll set up the interactor, set up the policy exactly the same as before. We'll want to put in the neural network that we trained and then enable the tick. And on tick is super simple. We're just going to call run inference on our policy. So this is, again, a learning manager base class. Super simple, not a lot to it. So we would take one of those, drag it on the map, and if we play, we can go ahead and go fight the guy that we trained in theory. He's down there. He's watching me. You can see he's a little twitchy. He blocked, but at the last possible second, so it's a little weird. So it certainly doesn't seem like it's great yet, but he's kind of doing roughly something. He's moving his sword more when I block. Blocked up, and he seems to kind of understand the directions. It seems like his timing's a little off. So that is after 2.5 seconds of training. So let's go ahead and then put him into reinforcement training. So we'll see how that works. So I'm going to take my imitation trainer out, or sorry, my inference guy out, and we will go ahead and load. So the inference, I'm not going to go over the inference training because the reinforcement trainer, because that is exactly what the existing Epic tutorial is about. So I won't go over that. This is just made exactly in accordance with their video on that. All that we need to do, is we need to tell it to use the asset that we set up. And then I'm not using this critic right now, so you can just ignore that. Then we want to be careful. We want to make sure this reinitialize policy network box when we call run training is unticked. Otherwise, it's going to wipe out the imitation learning. So we could compile that and drag it onto the level and simulate. Let me clear my log first. And so I have it set to delay a little bit before it loads it in so that all the agents are fully initialized and whatnot. So it spawned all these attackers that are behavior tree driven, and then the guy in the gray robes is going to be our guy who's learning to block. And he's going to be learning via reinforcement learning. And he's obviously having a bit of a hard time. That's probably the toughest opponent for him. This guy attacks a little slower. And you can see he's kind of trying, but he doesn't really get it yet. So you can play around. This is probably on the lower end of what I'd want to see from my imitation learning. I might have gone a little too far on not overfitting. So potentially I could save myself reinforcement training time by going back and training the imitation a little more. A sign that you would have overdone the imitation learning would be if your guy is super twitchy and kind of taking tons of really quick actions, or if they're standing there and kind of doing nothing. That would mean that you kind of zeroed out your network. Maybe this is actually pretty decent. I mean, this guy looks like he's got the general idea. It seems like his timing on his blocks is off, but he's not just standing there. He's trying, and he's probably blocking, I don't know, maybe half the attacks or so. As the reinforcement learning learns, if the reinforcement learning runs, we're going to be getting data on how it's performing. And if things are going well, this won't march steadily down every single chunk. You'll probably see some ups and downs, but it should generally be moving in a downward direction as they learn. In the Epic video, they were doing a much simpler problem. They were driving a car, and they kind of said you should see results after 15 minutes, and minor results after 15 minutes, and then it should look kind of good after 2 hours, but not human necessarily, just decent. I think with the with the initial imitation training, it goes faster than that, but you can let it run as long as you want to. Be prepared for it to run for a little while. But you can see already, you can kind of tell by how many blood splatters are on the ground. This guy's already blocking quite a lot of the attacks. He's not doing anything too crazy or twitchy. He actually looks a little bit like a human that's confused and blocking the wrong way occasionally, trying to fix it. One of the other things I set up here, he's looking a little twitchier there. I set up just him standing. This guy never attacks, so it's just you understand not to waste your stamina. And keep in mind, the training is going to be adding some noise to the actions. That's one of the learning parameters. So you wouldn't expect him to be totally still in training, even if he would be in production. The way the reinforcement learning works is it adds kind of some random chaos to what the agent would do. And then observes if that gave a better result than expected, and if so, increases the chances of that happening in the future. Now, the last thing that I'll mention before I kind of show a demo of what it looks like when it's done is that you can often, in addition to the training, so there's in a general data science viewpoint, when you're trying to train something, you would want to have good training data. In that case, our training data is what we recorded, and then kind of what kind of variety we're giving our agents in this reinforcement learning step. So that's why I have this guy attacks really fast and randomly. One of the other guys actually will kind of not attack if you're blocking the right way. So it's a little bit of adversarial training. There's the guy who just stands there. You definitely want to have variety in the training environment you're giving guys. That gives you good data. The other thing is to have a really clean controller that turns the outputs of the neural network into actions in a way that helps the agents learn. And so the neural networks are going to output a continuous variable, but we're either blocking or not, and then we're choosing a direction, which is all discrete. So if you're having trouble getting your learning to converge and you have a kind of discrete action space like that, one thing you definitely want to consider doing is to have the output drive a probabilistic choice of action. So instead of having some cutoff where it's like if the output is above 0.5, I block, and if it's below 0.5, I don't. That may make the learning very hard for the reinforcement learning. Instead, you could say the probability of me blocking scales with how high the number is. And that way, slight variations in the neural network's output can kind of gradually guide it towards the correct answer. When you have more of a cliff in your mapping of neural network outputs to agent actions, it's going to be a lot harder for it to learn. The final thing that you can do that I would try and avoid doing, but if it's really struggling to learn something, is you can go in, you can't change your inputs and your outputs of your network. Once it's trained, you'd have to retrain from scratch. But you can train the rewards anytime you want. You can change the rewards. So if you really notice, like, my agent just doesn't get something, you could add in temporarily an explicit reward for that thing, let it learn that thing, and then set the reward back. Anytime you put in weird rewards, you're always running the risk of unintended behaviors. So I would really avoid it. The imitation learning should mean you don't need to put in weird rewards. And so for my guys, the only reward they're getting is they get a reward for they get a negative reward for losing health, which happens when they get hit, and they get a negative reward for losing stamina, which happens anytime they block. So it's purely something that you probably would want to optimize in game. In game, it's not good to waste stamina. It's not good to lose health. But you could imagine setting up a reward that says, like, if my opponent's just sitting there, you get a special reward for not blocking. If you felt like this guy was twitching like crazy and burning stamina, that might be something you could consider to correct that specific behavior. I would try and avoid that. At some point, you should just write a behavior tree if you're having that hard a time getting it to learn the behavior, because you don't want your reward function to be some crazy spaghetti. But sometimes, in strategic ways, that can be a good technique. So if we look at our learning, it does seem to be kind of chunking down. It's gone from averaging up in the 20s to averaging in the high teens. There's always going to be some noise because, like I said, it's about how much damage you take. So just dependent on what, if you happened to block, if you imagine each time he's attacked, say he's got at his current strength, he's got a 70% chance of blocking the attack. If you get a few bad runs in a row and you get headshot for high damage, there's going to be a fair amount of variance in the reward function, and that's generally okay. The last thing I forgot to mention that is useful to know is in the trainer settings, which happens when you call run training. This one. The default settings they give you are assuming that you're training from scratch. You probably want to turn the learning rate down if you started with imitation learning, because you're not starting with an empty model, you're starting with a pre-trained model. Excuse me. And so that is just a good tip. And you can see we know it's working because this has the asterisks. It's kind of learning over time. And so what I'll wrap up with real quick is we'll go ahead and fight something where I went through the exact same steps as here, but I let it reinforcement learn for like 30 minutes or so. So to do that, we would need to put back in our inference manager. I already had one, never mind. And then we'd go into it and we'd change what it's working on to this one. And give it a second. All right, there he is. See, so I can feint and cancel my attacks to try and kind of fake him out. So I'll see if he blocks down, then I'll like switch to up. If I don't feint at all, he seems pretty. Oh, no, he's kind of freaking out when I feint more. So I think this would need more work, but it's not a bad proof of concept. And of course, he only knows about. Yeah, that's pretty funny. He only knows about things that are in range. So some of the or that he was trained on. So some of the other mechanics are like if you get kicked while you're blocking, you get stunned like that. He doesn't know not to get stunned, so he doesn't know to let go of his block. But if you just attack him, basically just a noise pass to clean up some of the twitchiness would be pretty good. I feel like he makes reasonable blocks. He struggles in situations that are similar to what a human would struggle with. Let's see what he does if I like come at him from weird angles a little bit more. I'm just swinging and missing, so it's not working. Yeah, so you got that. That pulls him. So I don't actually. There's no way to know what what variables he's reading from directly, but he has things like the velocity of my sword. So I was wondering if moving my body would mess with him some, but he seems to generally get it. And their mechanic in game, so the weapon charges up, and he's being told what my charge meters are, like how long I've been charging. But one of your abilities is to do like a quick shout that insta charges your attack. So, yeah, he has a hard time with the attack comes out faster than he expected. That's using my R ability there. So yeah, that's kind of 30 minutes of training, and hopefully you guys found this video helpful. So I mentioned that I didn't care too much about exactly how human-like his behavior was. I'll explain a little bit more about why that is, and if there's interest, I'll follow up on this. But one of my goals for this is to have a few different components. So one is that you don't need to directly map the output of your neural network to directly to action. You could feed the output of your neural network into a behavior tree and have it be kind of advisory. And so one of the things that I've worked hard on to do in my game is that the excuse me, all of the agents actually use the same behavior tree for the most part, unless they're calling special abilities. They can dynamically sub in a behavior tree that calls the ability, but they have pretty simple behavior trees. This is the entire offensive component, and it's parameterized by a set of parameters. And so you can have extremely different opponents in this structure that actually just involve changing some numbers and some booleans. So one of the things I'd like to do is to have the neural network actually be an advisor into the system, not to completely replace behavior trees with it. So if the behavior is a little twitchy at times, I'm not too worried about that because this would mostly be advising, in this example, this would be advising which way to block. But some of the areas that I'd really like to use the learning ages is actually things that are hard to do with behavior tree. Knowing which opponent to target is a tricky thing. And then the other thing is that I plan to do a layer later that is going to be adversarial selection, where there will be a classifier that is trained on recordings of both human and AI play and has learned to differentiate AIs from humans. And then the neural network will be punished by being perceived as AI. And the hope is that will let us train AIs that are actually kind of indistinguishable from human players. And so this is more just a proof of concept. And I think that a lot of the cleaning up will come in those 2 final passes. Now, just for the sake of posterity, I did do a simplified version of this earlier, where uh, I only allowed attacking in 2 directions, so just up and down. But I let the guy train for days in reinforcement learning and really try to make a perfectly polished version of the AI. And this is not that. This is the same guy we fought before. But he did end up, perfect. You actually couldn't hit him unless you kicked him because he doesn't know about kicks, and there was no twitchiness whatsoever. So it certainly is possible, but not in 30 minutes. If that makes sense. So the other thing I'd say is that even this level of behavior, if you don't use imitation learning at all, if you just try and get to this with reinforcement learning in isolation, I think there's a really high chance that you'll just get completely stuck and you wouldn't get anywhere. It really has a hard time learning some of these payoffs that are, the payoff it gets when it blocks is mostly it just loses stamina unless it really times it perfectly and gets the right direction. It has a very hard time figuring out. So I highly recommend using the imitation learning to make that process less painful. You could easily set up, depending on the structure of your game, you could very easily set up something that's pretty well structured and run reinforcement learning on it for days and just never get anywhere. So that is why I thought making a tutorial for imitation learning would be super helpful. So I've never made a tutorial like this before. If you guys have any feedback, please let me know on how it could be better. Hopefully you guys think the learning agents are as cool as I do. Thanks for watching.